Assalamualaikum and very good afternoon to all of you. So this is our last class for this semester. And okay, I think so for this class we will be discussing about the equivalent single phase induction motor. But before we proceed with that, okay, I just want to maybe tell you something about general informations about the induction motor. Okay, especially the application of the induction motor for the air conditioner. Okay, so we have two units of air conditioner. The first one is what you call the indoor units. Okay, we have where we have the blower here. Okay, so this is the indicator and so on. Okay, and this one is indoor unit. This indoor unit don't have anything. They just have a blower motor here just to blow the fresh or the cool air to the room okay. And then we have this is the voltage supply. So we have ground, live, and also neutral cables. And this power supply is shared with we have here the outdoor units. Okay, the outdoor units. So we have a fan here. Okay, so this is the outdoor units. Okay, this outdoor unit inside here we have what we call compressor. Okay, compressor is actually a motor. Okay, this is the main component for the air conditioner. Okay, but so this price is very expensive. It depends because it is actually the main component for the air conditioning system. Okay, so this is usually the compressor motor used is actually the induction motor, a single phase induction motor. Okay. Okay, so this is actually the conventional aircon. Okay, we have a conventional aircon, and then we have another one which has the same unit. We have the indoor units and we have the outdoor unit. But what we have here is actually what we call the inverter aircon, right? Inverter aircon. So I want to tell you something about what is the difference between the conventional and inverter aircon. Okay, because normally if, for example, if your house, your father and mother want to buy a new air conditioner, okay, so we go to the shop, and then the shop will introduce about two different, which is the conventional aircon. Are you want to use the conventional aircon, or do you want to have an inverter, where usually they will tell you that the inverter aircon is actually 50% reduction of bills. Okay, is it true? So it depends on how you use. Okay, so for example, if the air conditioner is used for 24 hours, for example, you use usually for daily use, meaning that from 8 a.m. to 12 midnight, you are always turn on the aircon, then yes, you will see the effect of using the inverter aircon. Okay, you will see that the bills will be reduced significantly. Okay, but if you are using the inverter aircon just for maybe the first 2 hours in your bedtime, your bedroom, so you will not see the reduction of bills. Okay, so it's actually inverter is useful, or is actually benefit for the person that is actually 24 hours turn on the aircon. Okay, so how and why this happened actually? So we need to go to back for the conventional aircon. So actually the conventional is actually the bills The high beat is because of the how we use the compressor motor. Okay, this is induction motor, and if I plot, it's actually related to the what we have discussed, the torque and speed characteristic of the induction motor. Okay, so this is actually a typical torque speed characteristic of a motor, and it depends on the frequency. So this is actually when the frequency supply is 50 hertz, for example. Okay, so we will have this curve. For different frequency supply, you have different torque speed characteristic. Okay, so and then to determine the speed of the motor here is actually when you have the intersection of torque speed characteristic with the torque load. Okay, so the intersection here will give you the what is the value of the motor need to rotate. Okay, and here this is where is we call this one is the no load speed, or sometimes also synchronous speed. Okay, so this is actually when this is a rated load, so meaning that this speed is actually a rated speed. Okay, the rated speed. Okay, so what I want to tell you about is we have ada banyak color lain. Okay, color green pula. Okay, this is the torque speed characteristic, and then this is your torque load. For example, we are using a constant torque load. Okay, and then we have maybe okay, so this is the curve. This one should be a linear, straight line. Okay, but okay, this is the current values. Okay, so we have torque axis and also current axis here. And as you can see here, this is where your motor is zero. So from standstill, okay, during the startup, as you can see, when you want to start the motor, the current will be very, very high. Okay, it's very, very high here. Okay, and when your motor is running at similar to the synchronous speed or the no load speed, you will see that the current will always very, very small. Okay, so that's why we always want to operate our motor, the speed of the motor to always at very near to the synchronous speed, meaning that your S is small, because we know that your S is the difference between synchronous speed with your motor speed over the synchronous speed. Okay, so when you have this upper side here very, very small, so you will have S very, very small. So we want to have this motor to operate at the nearest as possible with the synchronous speed to take advantage of the small current, because the bills is actually based on the current that we use, the amount of current that we use. Okay, the voltage is maintained 240 volt. That one we cannot change. Okay, all the socket is 240 volt. The only values that is actually will affect your bills is the current. So if you use more currents, so the bills will be very, very high. Okay, so that's why we want to have the motor to operate at the nearest possible with the synchronous speed. As you can see, we have a small current here. Okay, so why when okay, conventional and inverter, what is the difference? Why when we use inverter it can reduce the bills, and why when you use conventional the bill is very, very high? Okay, so let's look, or maybe if you have your aircon, okay, you will see sometimes you will set, for example, the temperature. You set the temperature is actually 25 degrees. 25 degrees. Okay, so you force the aircon, okay, to meet that values. This is actually your set point, right? For example, maybe your room temperature is 35 degrees, okay? So you force the aircon to reach this set point, 25 degrees. So this motor will actually rotate, and because it want to compress more air, okay? Because the higher the rotation, so the faster that it will reach the temperature, okay? So because it want to compress the hot air, so the hot air becomes cool air, okay? So, and then when it suddenly achieve this, maybe from 35 until I think maybe around 30 minutes or 20 minutes, it achieved this set point. So what happened to the compressor? What happened to the compressor? So right now the compressor is running because it want to reach this set point. But after it reached the set point, what happened to the compressor? Is it still rotating or it stopped? For the conventional aircon, yes, it will stop. It will stop. You will heard that kalau you pasang aircon, dah sampai satu suhu, set the set point, you will see that suddenly very quiet. Outdoor units will very quiet because it stop rotating. Betul? Agree with me? For the conventional aircon, it will stop. Okay? If you don't agree with me, then you turn on your aircon, and then after maybe you please carefully heard the compressor. Okay? You will see the whirring sound, and then after suddenly at maybe several minutes, you will heard that the sound is gone. Okay? Because the compressor is actually have already reached the temperature. Okay, that is actually the operation of the compressor. When it reaches the set point, so it will off because it already achieved that. But this blower, there is a difference between motor blower and motor compressor. This motor compressor is used to compress the air so that the air will become cool. Okay, this blower will keep rotating because it will blow the air, okay, inside the room. So this one is actually always rotating. When you turn on the aircon, this one will always rotate because it want to blow out the the cool air here. And then maybe several minutes, okay, maybe 4 minutes or maybe 5 minutes, this set point is suddenly increased to 26 degrees, for example. So what happened? This compressor will start rotating back, right? It will start rotating until it reach back to 25 degrees. Yes. So the on and off of this compressor actually referring to this one. As you can see, when it stop, okay, when it stop, the speed will reduce to 0. And then when the temperature is increased back, so it will start rotating and the current will, actually the starting current will be high, right? So if you imagine that every 5 minutes when this one is turned, when this compressor meet, and then when it meets the set point, then it will turn off, and then it turn on again, on and off again every time. Okay, so you see that you will have the current is always high until it reach to the point here. So the current is small. Okay, but when it reach the set point, then it will shut down, turn off. So the speed is 0. But when the room is getting hotter, then it will start back. So the current will actually start very high and then reduce. So this start-up current on and off will actually increase the bills. Okay? Understand? So, maybe ada tak orang tanya, maybe why the compressor need to turn off Why when we reach to 25 degrees, why the compressor need to turn off? Why we just leave it to turn, kita biarkan dia on kan? why we need to shut down the compressor? Every time when it reaches the set point, we shut down the compressor. Why? Sorry? Dengar Safwan?
It save more energy. Save current.
Yes, to save the energy current. Because when you see here, okay, when it reaches the set point, okay, when it reaches the set point, the speed will actually reduce. For example, maybe at this point, okay? So, actually, you can see that when this speed is actually at this point, for example, the current is high. This is the current. The current is high. So, and then rather than we keep the motor always on, so why don't we shut down? Right? Kalau if we always, yelah, you dah set point kat sini kan, and then you turn on sentiasa, always keep turn on, the current is actually operating at here. Okay? So, to save energy, what we need to do is actually we introduce this inverter. So actually inside that aircon, we have the AC supply, okay, 240 volts, and then what we need to do is to convert from AC to DC, and then from this one is what we call rectifier, and then from this DC we convert back to AC. This one we call inverter. Okay, so and then we have this one is your motor. So single phase motor, this one inverter. So here the inverter will actually control the frequency. So right now the frequency, for example, is 50 hertz. So by using this inverter, we can have maybe 30 hertz, 40 hertz, maybe 1 hertz, or maybe 2 hertz. Depends on the characteristic of the motor that we want. For example, right now, when it has reached this set point, okay, by controlling the frequency, because right now this is actually the characteristic depends on the frequency supply. Okay, so right now when we want to the motor to always turn on, but okay, to always turn on, what we need to do is actually we change the characteristic of the motor so that, for example, maybe this one frequency supply is 10 hertz, for example. Okay, so that so right now this is the new synchronous speed. Okay, so as you can see here, this is your new motor speed. Still, you can see that the slip is small, and this is the new current characteristic. Okay, so this current characteristic is actually what I call is actually proportional with the frequency supply. So if the frequency supply is changed, so also the graph for the current is also changed. So as you can see, this inverter aircon is actually what the difference is actually this inverter aircon, the compressor will always running. Okay. Even though it had reached the set point, for example, 25, from 35 degrees to 25 degrees, and then suddenly, since it has reached the set point, so the speed of the motor will reduce. Okay, but since the when we reduce here, for example, at this point, okay, so we adjust the inverter so that it produce a frequency supply of 10 hertz. Okay, so that the sleep is actually very, very small. Okay, and the current is maintained at a very small value. So that is actually how the inverter operated, inverter aircon operated. So it will always turn on. Okay, so that's why for the person that is always use 24 hours aircon, so they will have that advantage. But when you are just using inverter aircon just for sleeping, for example, maybe 1 or 2 hours for the first 1 to 2 hours of your sleeping hours, so you will not see the difference, because after 2 hours you will shut down, right? It will shut down. So no different. So if you want to buy air conditioner, the purpose is for sleeping purpose, or maybe it's just a casual usage. Maybe within 1 month, maybe you use it maybe several times only. Okay, for the whole your living room and so on, or for your sleeping time for 2 hours. Just opt for conventional aircon. So that is my advice. Okay, just use conventional aircon because actually the price conventional and inverter aircon, the price is quite huge. The price different. Okay, rather than you are buying this inverter, so it's better to use conventional because all the equipment, for example, the hose, and then the maintenance, and then the installation, the inverter aircon is much expensive compared to the conventional aircon. Okay. Okay, I think that's all for the general information. From the chat, I hope I have answered the question. Okay, so actually the difference between the conventional and inverter is actually we use inverter to control the frequency supply. Okay, so that we can modify the top speed characteristic of the induction motor. But this one will not be inside your syllabus and will be not inside your final exam. Okay, this is for your general information. Maybe your friends or maybe your family ask you what is the difference between conventional and inverter. I hope you can explain to them. Okay, when conventional, you use this single top speed because the frequency supply is fixed 50 hertz. Okay, but when you use inverter, we can adjust this top speed because we can actually vary the frequency supply from 50 hertz to 30, 40, or 1 hertz, or maybe 2 hertz, depends on the operation of the induction motor. Okay, so I think that's all. So let's move on the single phase equivalent circuit. Okay, so this one. So I just go brief lah for this last lecture here because all the explanation have been explained in my YouTube videos. Okay, so this is just for maybe to highlight something. Okay, so we know that since the induction motor, three-phase induction motor is, we assume it is a balanced load, so we can actually do our analysis using a single-phase equivalent circuit. Okay, so as you can see here, we have R1. It's actually like a transformer. Okay, so we have here R1, which is a winding resistance. Okay, then we have X1, which is referring to the what? This one is actually we call leakage. Okay, leakage reactance. Okay, because L is actually leakage inductance. So when X, this one is referring as a leakage reactance. Okay, and then RC, we have also RC here. So this one is actually core losses. Okay, and then another one is XM, which is the referring to the magnetization inductance or reactance. When you use XM, so this one is actually magnetizing reactance. Okay, when referring to LM, so this one is actually magnetizing inductance. Okay, so we have the voltage supply here, and we have E1 here as your what I call the induced voltage. Okay, induced voltage at the stator. And then at the rotor side also we have, this is the coil, and then we have SE2. Okay, this one is actually E2S. Okay, so E2S, so which is, what is E2S? It is actually the induced voltage due to the, and the value is actually depends on the slip. Okay, what E2? E2 is actually induced voltage at standstill, meaning that when your S is equals to 1. Okay, so when S is equal to 1, the voltage induced is the maximum, which is E2. Okay, and then it will reduce when the slip is reduced, so we will see that the voltage induced will be also reduced. So this is actually when your slip is 1, because we know that your frequency roto here, because we know that there are two frequencies. Okay, the roto frequency, which is F2, which is actually SF1. Okay, so when S is equal to 1, so your F2 is F1. So that's why E2 is actually induced voltage at standstill when your frequency is F1. Okay, so I hope you know what is F1. So F1 is actually the frequency at the stator. Okay, we have stator circuit and rotor circuit. So stator, the frequency is F1, and at the rotor circuit, the frequency is F2. And the relationship between F2 and F1 is actually F2 is equal to SF1. Okay, and then we can see we have a current I2 here flowing, rotor current, and then we have the reactant, which is SX2, and we have R2 here. Okay, so the current rotor, this one is the rotor current, R2. So this one is the voltage over the impedance, the total impedance, R2 plus J SX2. And then this is actually the rotor power, which is P2. How you calculate P2 is actually, this is the real power, okay? So meaning that you just need multiplication of I square multiply with R2, okay? Okay, R2, because only resistor that absorb power, okay? Please note on that. Don't multiply with X and so on, okay? So this is actually all the equations, but as you can see, we want to what we call to simplify our calculations. So what we do is actually we transferring. Okay, we rewrite these equations. Okay, rather than we use SE2 and also XX2, so we modify so that it will become like this. So it will have E2. What is E2? Is actually the voltage induced at standstill. Okay, and then we have X2. Right now, this one is X2, but when we modify it, it will become X2. And then we have here, the resistance right now is not fixed. It's a variable resistance where the value is depends on R2 over S. Okay. Okay. And this one also is because R2 here, R2 over S, it has, there are two information that actually embedded inside this R2 over S. Okay, so to divide or to extract the information, what we do is we divide this one into two resistor values, which is R2, and then another one is R2 R roto over S, 1 minus S. Okay. But this one, if you add up again, it will have these values. Same. Okay. Because this R2 is actually referring to the P roto. While this one is actually represent the P mechanical output. Okay, that's why we want, because this R2 over S has two information about power. The first one is the P roto, and the second one is the mechanical output. So because of that, so to simplify our analysis, so we extract, or we actually expand this one into two element resistor, which is R2, and this one is R2 over S, 1 minus S. Okay. And this one is power air gap, because we know that when we want to transfer from E1 here to E2, okay, so this transfer is actually what we call P air gap, okay, which is the inputs for the roto, okay. So as you can see here, P air gap is equals to P roto over S, or we can say that P roto is equals to the fraction of the air gap, because S we know is a slip from 1 to 0, right? So meaning that your roto power is the fraction of the power air gap, which is the power that transferred from stator to the roto. Okay, so this one, as you can see, this is the simplified version of the single phase equivalent induction motor. We have the stator part, and then we have the core. And then right now, as you can see, we transfer all the element at the roto side. So I think you need to memorize this. Okay. But still, as you can see, this model is not convenient to use to predict the circuit performance. Still, even though we have transferred all the roto side into a stator side, okay, still this circuit is too complex to be analyzed, okay, to predict the parameters performance of the induction motor. So what we need to do is actually this one, as you can see. Oops. Oh, this is example. Okay. What we need to do is actually we do some modification on the circuit. So right now, as you can see, R1 and also X1, which is originally placed at this part, has been transferred after RC and XM. As you can see here, this is the new equivalent circuit, approximate equivalent circuit. So right now, R1 and X1 has been transferred. Okay, because based on the analysis that they have done, this R1 and X1 has what I call, actually RC and XM actually has a very small effect during on the calculation. Okay. And then as you can see also, based on their finding also, we can see that RC is also removed from the circuit. Okay. So this one is actually approximate equivalent circuit, but the standard equivalent circuit, which is recommended by IEEE for the analysis for induction motor, they are using this equation. This circuit. Okay, this is approximate. Okay, this is approximate equivalent circuit, meaning that we have two equivalent circuit that we can use. This is a first, which is we call approximate equivalent circuit, and the second circuit here is the most recommended equivalent circuit to be used for the analysis. Okay. And to get these parameters, okay, these parameters R1, X1, Xm, and R2, we need, it's actually same like a transformer, okay, to get this value. So we need to do a test. So we have what we call the no load test, okay, and the block roto test, okay. So this one, I think during your, I think most of you have already take this lab, the machines lab, this semester? Not yet. Okay, I think, oh, so this is your second semester. So you will actually entering this lab, machines lab, on your third year, semester 1. Okay, semester 1. Uh, this is semester 1, right? Semester 1, and next semester is semester 2. So on September 2022. Yeah. For is, yes. For those who actually under SKEE 2423, they may have take this machine lab this semester. Okay, but for, I think for new student SEE 2423, you will entering this lab on September. I think September. Yeah, September 2022. Okay. So actually all the information has been described actually inside my pre-recorded video. Okay, and also I have it's actually same like the transformer actually. Okay. So let's do the examples, because this example, I think I have don't have the solution, but this one is a very simple one. So this one is actually referring to the what we have discussed on the power and so on. Okay, so a three-phase 15 horsepower 460 volt. So please be reminded that this one is a V line. Okay, because it's a three-phase. So the number of pole is 4. This one is your frequency supply, and this is your rated speed, 1728 RPM. And it delivers full output power to the load connected to its shaft. The windage and friction loss of the motor is 750 watts. So this one is actually P mechanical losses, okay, which is we didn't cover. This one you just use the values. Okay, so determine the mechanical power. So this one is said that it delivers full output power, meaning that it delivers the rated output power. So 15 horsepower is equivalent to maybe 750 watt. 1 horsepower is equivalent to 750 watt. So 15 horsepower multiplied with 750 watt, berapa Calculator tak ada pula. Can someone 11.19. 11.19 kilowatt, which is this one, right? Okay. So I think there is a slight difference. It's okay lah, still acceptable. Okay. One because we know that 1 horsepower is 750 watt, and the information given here is actually the motor is deliver full output power, meaning that it delivers its rated power here, 15 horsepower. So 11.19. 11 point, is it 11.19? Oh, bukan. This one berapa 1 horsepower is equivalent to, can someone Google 1 horsepower just to make sure 1 horsepower is equivalent to what? What? Because okay, oh sorry, 745. Oh sorry. 745.7 watt. So 745.7. So can someone calculate back what is the total output power? So meaning that 746 lah So we use 746. So 11.185. Okay. 5. Okay. 11.1855 kilowatt. Okay. So this is actually the P out. Okay. Because we know that the mechanical, this one your P out, this one is your P max losses, and this one is the P mechanical output. So right now your P mechanical, what you need to do is actually to sum up P out plus the P max losses. So 11.1855 kilowatt plus 750 watt. You should get around these values also. P mechanical is equals to P electrical, this one, okay? P electrical. Which is, this one is equals to what I call P develop. Okay. Okay, can someone maybe, okay, so 11.935, okay lah. So accept So 11.935. 35 kilowatt. Okay, acceptable range lah. Okay, so this is the mechanical output, okay, which is equals to P, what I call P develop, okay, and is also equal to the P electrical. So right now, what is the air gap power? So the air gap power, we know that we have P roto or P2, which is P roto, which is equals to the P output of the mechanical, okay? P mechanical is equals to the fraction of your P air gap, right? S P air gap. Mana tu? Okay, so right now, the P mechanical, we have already know, right? 11940 watt. So this one we obtain, but as we don't know to get what is the P air gap. So we need to find what is the slip value, because the P mechanical is depends on the slip value. So right now the slip value is not known, but we can calculate it. So the information here is deliver full output power, meaning that this motor is operated at its rated values. Okay, meaning that it will rotate at the rated speed. The frequency supply is 60 hertz and so on. Okay, so from here you can get your speed of the motor 1728 RPM. Okay, we need to calculate what is the synchronous speed, because sleep is actually N sync minus Nm over N sync. So N sync is you use 120 multiply with the frequency supply over the number of pole. So this one 120 multiply with 60 over 4. So this one you should get 1800 RPM. Right? So your sleep will be, okay, you just substitute the value 1800 or minus 1728 over 1800, 0.04. There is no unit because this is just a ratio. Okay, so and then from the equation we know that P roto, which is equivalent to the P mechanical, is equals to S P air gap. Okay, so your P air gap, P mechanical is 1194 watt over 0.04. So you should get around 12437.5 watt. P air gap is actually the power input to the at the rotor, at the rotor side, because from the stator, okay, and then from the stator it transfer the power to the rotor. So right now the source of the power at the rotor circuit is P air gap. Huh? Salah ke? 29 Pelik 11940 over the slip 29. Apa yang silap What is wrong? Oh, sorry. This one. Sorry. Oh, P2. Sorry. Yes. I'm very sorry on that. So P2 is actually P roto. So P roto, and then this is the P mechanical. Sorry. So meaning that this is wrong. So actually this, yeah. This is all wrong. Okay. P roto is not P mechanical. Sorry. Okay. Sorry on that. Actually, we know that your P air gap is actually have P roto plus P mechanical. Okay, so I am very sorry. The P roto is not P mechanical. P roto is actually the losses. to the rotor side due to the R2. Okay, sorry for that. So P rotor is not P mechanical. Okay. So this one is actually, you can see that from here, the P mechanical that we have already obtained, which is 119451, is equivalent to 1 minus S, P air gap. Okay, sorry for that. This one, you need to use this. Okay, P mechanical is 1 minus S, P air gap. Because from here actually, P air gap is equals to, this one is your P roto, which is S P air gap plus P mechanical. So we transfer this one and then transfer to this one. So that's why we have P mechanical is equals to 1 minus P air gap. Okay. Sorry for that. Thank you for letting me know. So meaning that this one is P air gap is equals to 1 minus S P mechanical. So this one meaning that 1 minus 0.04. Okay, sorry for that. Should get 12437.51. Okay, and the last one is the Roto-Copper Loss, which is P roto, which is from here we know that is actually S P air gap. So right now we have already get the P air gap, and then we have also the slip. So the P roto is equals to 0.04 multiply with 12437.5. So should get 497.51. So this one is your P roto or P2. Okay, I think that's all from me. And I am actually marking your second test 2, still not finished yet. But mostly, most of you have done some minor mistake, but it actually affect your answer. Usually for the transmission, no problem on the first question, which is on the generation, hydroelectric and the coal generation. The problem is when for the transmission line. Okay, if you remember the question, the load is actually 500 kVA at power factor 0.8. Okay, and usually the current load, okay, you use this one, right? P load is equivalent to square root 3 V line I line cos theta, right? So this one is P, because most of you use this equation. P load over square root 3 cos theta, right? Most of you use this one. Yes, this is the correct equation you need to use. Okay, the only problem is actually the values of the load here. Most of you put 500k, 500k, without noticing that this 500k is actually VA already inside the question. VA is not watt. Okay, so what you need to do is actually to convert. This one is actually your apparent power, S. So what you need to do is actually just to get your P is actually S multiply with the power factors, which is you should get 400k. Instead of using 500, you should use 400 kilowatt here. So this will affect your answer. So I will, as mentioned before, I will not penalize the student. Okay, if I see that they actually know, so but the marks will be deduct from that because of this mistake. Okay. So I will, inshallah, will try to finish marking all. So I will give you the carry marks without the assignment 2, because the assignment 2, if not mistaken, the deadline is 1 day before your final exam, right? Okay, so I give you time. So it depends on if all of you have submitted assignment 2. Okay, so I will try my best to complete all the marking for the assignment 2 and all assignment 2, assignment 1, and so that before the final exam, maybe several days, you will have uh, your carry marks. Okay, I think the carry mark is 50% from the totals. Okay, may I know? I also forgot what. May I know when is your final exam? Because I have 2 subjects for this semester, so quite confusing. So 14th of February. Okay, thank you. So meaning that the deadline for the assignment 2 is 13th of February. But if I see that most of you have submitted the assignment 2, then I just give you the marks for the assignment 2, and then before that you can have that marks, the complete marks. Okay, for the carry marks. Okay, for that, I think thank you very much and for all your cooperation throughout these semesters. So this is a very hectic semesters because online, and I know most of the students also have less motivation. Okay, maybe in the first few weeks, okay, but after that, maybe because of their some problem on here and there, then the motivation is keep what you call down, and so in the downtrend, because it's not student only, the lecturers also. Most of the lecturers are what you call in the very not very good motivation to teach actually. So we hope that for that specific is face to face, but we know we have received the circulation that next semester will be also online, but we as a lecturer will request to the university so that at least the lab session will be face to face. That one we try to request, okay, because it depends on the school whether it is will be practical or online. But I think most of the lecturers want the lab to be face to face lah. Okay, because we see that the effect of this COVID during the final year project presentation, which is last week. So most of the students actually don't have experience in handling the oscilloscope. Okay, because I think 2 years online, so they don't have experience on the lab. Okay, so maybe they forgot on how to handle this oscilloscope, how to handle the voltmeter, the multimeter, and so on. Yeah. So you are from year 1. So this one, I think, is almost 3 years. Today, I think today is the the anniversary for the COVID in Malaysia. The first case in Malaysia is today, detected 3 years ago. From Singapore, right? Singaporean. They went for not Singaporean, Chinese. They went to Singapore because of the Chinese New Year, and then they come inside to Malaysia. So pity for you. So you don't have any chance on getting to the campus. But I think most of you are inside the campus. But the live campus, okay, going to the class and meet friends in the class, meet the lecturers. We are actually the lecturer also missing that moment. Okay, I think that's all from me. Inshallah, we try my best to complete all your carry marks. Okay. So if you have any problems or maybe you want to clarify something about this topic, then you can just reach me. Okay. Okay, I have so final chapter 4, stop until equivalent circuit. Yes, until equivalent circuit. That is what we have been told by our coordinator. So the final exam will be only theoretical. So mostly on the equivalent circuit. And I think for in a safe side, okay, maybe you should watch the videos on how to obtain the parameters. Okay, for example, the R1, X1, X2, using what experiment, okay, which is I have shown earlier, the no load test and also the block rotor test. So I think you need to watch that pre-recorded videos. Okay, because in the lab, okay, Fauz Ibn Harun with me in this semester for that lab machine. So we actually will ask the student to do the experiment again, and then from that experiment obtain which is the no load test and also the block rotor test to get the equivalent parameters. Okay, so I think you need to look at that because it will be in your third semester. Okay, lab machine session. And okay, I will upload. Yes, I will upload soon in the WhatsApp group. Okay, I think I put this. Okay, thank you very much. I think that's all from me. Assalamualaikum and have a very good day.
You too.